So good morning, everyone, and welcome to this session. In this session, we are going to start with thermodynamics, and we are going to deal with calorimetry and thermometry to begin with. This is the beginning of heat, so we'll see all the terms that are going to come, and we'll try to cover it in as much details in as much short time as possible. The first thing whenever you hear about thermometry or calorimetry or thermodynamics is the word heat. I told you to go through this topic before you come to the class. Have you gone through this topic before the class?
Yes, sir.
Okay, then tell me, what do you mean by heat?
Heat is a form of energy.
Heat is a form of energy. So heat is what form of energy? So it's a form of energy, and I use the word in transit. In transit, this in transit word means that heat is only defined when it is moving or when it is flowing from one body to the other body. Yes or no?
Yes, sir.
The SI unit of heat is joules, and one more unit that we use is calorie. You can call that as the CGS unit. The CGS unit is cal, and you must remember the relation between calories and joule. What is the relation? What is the relation?
4.1
One
4.2
calorie.
joules, sir. 1
Yes,
calorie.
1 calorie can be taken as 4.2 joules. I hope you all understand this, and you must also remember what is the definition of 1 calorie. What is the definition of 1 calorie? It is the heat required to raise the temperature of 1 gram of water by 1 degree Celsius. Do you know this?
Yes,
This
sir.
rise of temperature should be from 14.5 to 15.5 degrees Celsius. We know this, yes or no? That much heat is required. That much heat is defined as 1 calorie. Previously, when this unit was when this unit of calorie was defined, we did not consider heat as a form of energy. That is why this separate unit of heat was there. Heat is a form of energy, so its unit is joule, and the dimensions are ml square T minus 2. Do we understand this?
Yes, sir.
Okay. Now remember, work can be converted. Work and energy are related to each other. If you have energy, that means you have capacity to do work. Heat is also a form of energy. That means if you do work or if you have energy, that energy can be converted into heat. The small problem is the entire work or entire energy cannot be converted into heat. For example, there is a body which is falling. It has potential energy. Now, when it falls, some part of that energy gets converted into heat. Not the entire part can be converted into heat. Do we understand this? But work
Yes,
or
sir.
energy can be converted into heat. Yes or no?
Yes, sir.
And we can use this formula: work is equal to JQ. Do we remember? Do we understand this formula? This W over here is work, this Q here over is heat, and this J is known as mechanical equivalent of heat. Do we understand this?
Yes, sir.
This J, this J is known as mechanical equivalent of heat, and the value of this J is simply 4.2 joules per calorie. Have you got that sheet that I sent you?
Yes, sir.
What did you get? This was
Yes, sir.
exercise 1, right? What did you get? Show it to me. I can't see. I don't have real eyes. Show it to me. What did you get? Yes. That, yes. Well done. Got it, got it. That I just mailed 15-20 minutes back, and you have got it. So that is quick service. Well done. So we assume that if we assume that the entire work can be converted into heat, this is the formula that we can convert heat into energy into heat. But remember, Heat is also a form of energy. This is basically converting the energy from joule to calories. So this formula, this J, basically converts energy in joules to energy in calories. Do we understand this?
Yes, sir.
This J converts what? This J
Into
converts
calories,
what?
sir.
This J converts energy in joules to energy in calories. Okay. Now there is a small question that I will put. Tell me the answer to this, fatafat. Remember, the answer has to be given in calories. What is the change in potential energy in calories of a 10 kg mass? This is from your module only. After falling through a 10 meter, 10 meter height, you can take acceleration due to gravity G as 10 meter per second square. The sheet that I have sent you, if you can do that sheet, it does not have many questions. If you can do that sheet, there would be some questions which you will not be able to do, because there would be some questions which are taken from the parts which are going to come in the future. But most of the questions you should be able to do it, and this will cover your entire topic of calorimetry and thermometry. We'll try to do as many questions as possible in the class. This is the first one. This is not from the exercise. So how do you do this, bacha? How do you solve this? Yeah, so you just say the change in potential energy is equal to M into G into H. M is I think 10, G is 10, and H is also
1000,
10.
sir.
So this is 1000 joules. 1000 joules. You just divide this 1000 joules by what? 4.2 and 4.18 is the exact value. You can just divide it by 4.2 and you end up with your answer. Yes or no? No, yes.
Yes, sir.
Yes, sir.
Got this? Okay. See, the question that are going to come in the exam may be very, very simple. Just like this one, this is the first question from your sheet. And you can give me the answer quickly. What is the answer for this one? You don't have to write the question. The question is already there on your table, and you can see it and read it here. Yes. The amount of heat required to raise the temperature of 1 kg of water through 1 degree Celsius.
Kilocalories.
It would be kilocalories. Do we all understand this? Yes or no?
Understood, sir.
Both the class. I mean, I can't see the other class. They have not joined or what?
Joined, sir.
Okay. So things are pretty simple, and we will keep them as simple as possible. The sheet is there. We will keep coming back to the sheet when and wherever it is required. Right now, the next point that we must understand, the next heading that we must understand is the heading of temperature. The next heading is the heading of temperature. Yes, bacha, the class. You can hear me, you can see me. Audible, visible. You have gone again. Anyways, temperature. What do you understand by the term temperature? Yes.
Degree of hotness or coldness.
Well done. You can call it the degree of hotness or the degree of coldness of a body. To tell you or to understand how hot or how cold a body is, whatever we use is known as the temperature. What type of quantity is temperature? It is a scalar quantity. What is the SI unit?
Degrees Celsius.
SI unit is Kelvin. The CGS unit is degree Celsius. Okay. Remember, this is one of the 7 fundamental quantities. This is one of the 7 fundamental quantities that we have used. Remember that mass, length, time, temperature, that's the fourth one basically. Ampere for current, luminous intensity, and mole. These are the 7 fundamental quantities. Temperature is one of the 7 fundamental quantities. Do we understand this?
Yes, sir.
Okay. Now, you must understand the difference between heat and temperature. You must understand the difference between heat and temperature. We say that heat flows because of difference in temperature. Do we know this? Whenever I write heat, I will write it as delta Q. Why will I use delta? Because this delta basically means, if you remember, this delta basically means change. And why do I use this delta? Because I must always remember that heat is only defined when it is moving. When it is going from one point to the other point, then only it is called as heat. When it is inside a body, for example, if I say that 10 calories of heat has been transferred from point A to point B, my statement is correct. But if I say that I have 20 calories of heat inside me, that is the wrong statement. Heat is not contained inside a body. Heat is only defined when it is getting transferred. So I can lose heat, I can gain heat, but I don't have heat in my body. Do we understand this? So heat is only defined when it is moving, when it is in transfer, when it is getting transferred. And that is why I'm going to use delta Q. Why does heat get transferred? This heat gets transferred due to what? Due to
Change in internal.
delta T. Or I will not write it delta T, I might write it as delta theta, because for temperature I might use theta. T is normally used for time, so I use theta for temperature. Do we understand this? Heat is
Yes,
only
sir.
defined when it is moving from one point to other. When it is inside a body, it is not defined as heat, it is defined as internal energy. Do we understand this? When it is inside your body, it is not heat, it is known as your internal energy. Now, this internal energy is written by the letter U, and that is directly proportional to T or theta, depending on what you call temperature as. Remember, this T or theta must be in kelvins. And then this internal energy is in joules. So the internal energy of a body depends on the temperature. The heat does not depend on temperature. It depends on what is the temperature difference between one body and the other body. And heat always flows from
Hotter body to colder body.
from hotter to the colder body. Do we understand this?
Yes, sir.
Heat, temperature, internal energy. 3 terms. I hope the 3 terms are now quite distinct. Now, whenever we talk about temperature, there must be something with which you can measure the temperature. That something is known as, that something that we use to measure temperature is known as
Temperature scale.
temperature scale or a thermometer.
Thermometer.
Now, every thermometer, every temperature scale that we have made, it depends on some property of a body that changes with temperature. With time and with experience, we have found out that there are certain properties of a body, certain properties which changes almost linearly. When I say linearly, in a straight line, there are some properties of a certain body changes linearly with change in temperature. Can you name some properties of substances that change with change in temperature? Yes. Do you understand my question? Every temperature scale or every thermometer is based on certain property of something that changes with temperature. Can you name certain properties that change with change in temperature? Yes.
Pressure.
Yes. So certain properties do change with change in temperature. Properties depending on temperature. Depending on temperature. Now, you have seen that if you have liquid and you increase the temperature of the liquid, volume of the liquid rises. Yes or no? So
Yes, sir.
volume of the liquid is one property that changes when temperature is changed. Now, if you put that liquid in a small tube, we call that small tube as capillary tube. When the temperature increases, the volume of the liquid will increase, and therefore the length of the liquid in the capillary would increase. Yes or no?
Yes, sir.
This length of the liquid changes because of change in the volume. Pressure of the gas at constant volume. If you keep the volume constant, P is equal to nRT, ideal gas. If you keep the volume constant, the pressure of the gas is directly proportional to the absolute temperature. Yes or no?
Yes, sir.
Similarly, the volume of the gas, if you keep the pressure constant, directly proportional to temperature. Yes or no?
Yes, sir.
Resistance of a wire. If you increase the temperature of a wire, platinum wire or any wire, the resistance of the wire changes, and that property of change of resistance can be used to create a temperature scale or create a thermometer. Do we understand this? So every thermometer or every temperature scale that we have will depend on any one of the properties listed on your screen right now. Do we understand this?
Yes, sir.
Yes,
Now,
sir.
to measure temperature or to measure anything, we must have a zero. Without zero, nothing will make sense. Yes or no? So we have different scales, and therefore we have different zeros that they have called. Now remember, to make a scale, we need a reference point. To start with, every scale was based on water. So there are two special processes of water that were taken as reference. One was the melting point of water or melting point of ice. The other was boiling point of water. So every scale that we have made was based on what are the values given to this melting point and the boiling point. And remember, these were arbitrary values given to them. Do we understand the meaning of arbitrary? Every temperature scale that was made, they gave random values to melting point and boiling point. And then depending on that, we had our temperature scales. Am I making sense or am I talking nonsense? Do we understand this, bacha? What I'm talking?
Yes, sir.
So here are the different scales that you might have heard about and their symbols and their lower fixed point. Every scale had a lower fixed point. What is that lower fixed point? What does the lower fixed point basically mean? The lower fixed point basically refers to the melting point of water or ice. Do you understand this?
Yes, sir.
The upper fixed point of every scale basically refers to the boiling point of water. So they were given arbitrary values. For example, on the Celsius scale, which is degree Celsius, the symbol, boiling point of water was called 100 degrees Celsius and the melting point was arbitrary called 0 degrees Celsius. In between 0 and 100, they made 100 equal divisions. So one division was equal to 1 degree Celsius. That is how Celsius scales were made. Do we understand this? On the Fahrenheit scale, the melting point of water or ice was called as 32 degree Fahrenheit. The boiling point was called as 212. Number of divisions were made were 180. So one division equals to 1 degree F. Then we had Rumer scale, no one uses it, no one is going to ask you that. Then we had Rankine scale, no one uses it, no one would ask you that. We have Kelvin scale, which is the SI scale. The lower fixed point, the melting point of ice was taken as 273.15. Why it is so peculiar? Because it actually came by experimentation. That is why it is so peculiar. Boiling point 373.15. It also has same divisions. That means the number of divisions on the Celsius scale and the Fahrenheit scale are equal. That means 1 degree Celsius. the change of 1 degree Celsius is equal to the change of 1 Kelvin. Do we understand this?
Yes, sir.
You know this? You just need to note down or remember the upper and the lower fixed point of at least these three scales, because these three are the scales that will come in the examination. All the other two are redundant, they are hardly used. Have we noted it down? Bacha?
Noting, sir.
I'll give you 2 minutes. Once you're done, please let me know. What happened to the camera of the other class, beta? It's not working?
Not working properly, sir.
Okay, okay. You can hear me, right? You can see me.
Yes, sir. Yes, sir.
Okay. Doesn't matter. What matters is that you hear me and that I am visible. 2 minutes. Once you are done, please let me know.
Done, sir. Written.
Done, sir.
What about the other class? We are done.
Noted, sir.
Sir.
Okay. Then comes the formula that has everything inside it, and that formula is the formula for scales, different scales. You can make any scale that you wish based on the properties that we have shown, but whatever scale you make, obviously the upper fixed point has to be boiling point, the lower fixed point has to be melting point. Whatever scale you make, this formula has to be followed. What formula has to be followed? I hope you know this. Yes or no? This formula
Yes, sir.
has to be followed for each and every scale. The reading on that scale minus the lower fixed point divided by upper fixed point minus lower fixed point must be constant for any scale that you create. This is valid. You can see number 1 is Celsius scale, C minus 0 divided by 100 minus 0. Number 2, Fahrenheit scale, F minus 32 divided by 212 minus 32. Kelvin scale, K minus 270, 3.15 divided by 100. All these formulae are valid if I make any scale which is Arctic scale, and I call the temperature as A minus melting point of water divided by my scale boiling point minus my scale melting point. This must be a constant for any scale that we create. Do we understand this? This formula will help
sir.
us in converting what? In converting temperatures from one scale to the other scale. Do we understand this?
Yes, sir.
Okay, I'll give you a short problem from your sheet only. You don't have to write the problem, you just have to see the problem and tell me the answer. This comes, and I think this is question number 13 from your sheet. A temperature difference should be difference. A temperature difference of 5 degree on the Celsius scale corresponds to how much on the Fahrenheit scale?
$41 degrees.
Yes, beta?
41, sir.
41, so much. Are you sure? No, I'm just asking you. I'm not sure. I have not done this question, so I'm not sure. Are you sure? How did you get it? That is more important. 41 if you got. How
Yes,
did you get
sir.
it? 41, everyone?
Yes, sir.
Can you show how does it done? Can you tell me how it is done, beta?
41, sir.
41. How it is done? How did you get it?
C by 100 is equal to F minus 32 by 212 minus 32.
Okay. Please tell me the formula. I forget formulas. Okay. C by
100
well done
is equal to
is equal to
F minus 32
Sir, 9 degrees.
low. Now we have different answer. Okay. Okay.
by
Correct.
180.
By 180. So how did you find it?
Putting
You
C
just
as
put
5,
C as
sir.
5 degrees. Yes or no?
Yes, sir.
Okay. Wait. Yes. Someone was saying 9. How did you get 9, bacha? This is how we get 41. I understand this. How did you get 9? Someone said 9. How?
Sir, I considered lower fixed point on Celsius scale is 0.
That is true. You have not considered it is true. Yes.
So temperature difference is 5. So my reading is 5 degrees Celsius.
Okay.
And on Fahrenheit scale, I got 41 degrees.
Okay.
And in Fahrenheit scale, lower fixed point is 32 degrees.
Okay.
So the difference is 9 degrees.
The difference is 9 degrees. Well done. You have said the correct thing. Remember, we had to find out what would be a difference of 5 degree is equal to on the Fahrenheit scale, not 5 degree. How much is 5 degree on the Fahrenheit scale? We have to find out if there is a temperature difference of 5 degrees on the Fahrenheit scale, what is the temperature difference on the Fahrenheit scale? From Celsius scale, temperature difference had to be converted to temperature difference on the Fahrenheit scale. Do we understand this? So what you have done here, my dear friends, is you have put straight away C as 5. That means you are converting 5 degrees Celsius into Fahrenheit. That is correct. That is 41. But that is not the difference of 5 degrees Celsius. Do we understand this?
Yes, sir.
How do I create the formula for difference? It is very simple. Now see, I have this formula C by 100 is equal to F minus 32 by 100. I differentiate both sides. You understand differentiation?
Yes, sir. Yes, sir.
Then you are done. Delta C by 100 will be equal to delta F by 180. Yes or no? Because 32 ka derivative will be 0. Yes
Sir.
or no? No, yes.
Yes, sir.
Then, sir, you have the formula, sir. Can you tell me the formula of difference in temperature then? So you got trapped in the first question that I put. So delta C, change in temperature on the Celsius scale, will be equal to 5 by 9, I think, right? Delta F. Do we understand the formula now?
Yes, sir.
And similarly, you can create formula for change or difference of temperature. The formula that I had given you was to convert from Celsius to Fahrenheit and not the change in Celsius to change in Fahrenheit. Do we understand this?
Yes, sir.
That was question number 14. Everyone got this? Can I have raise hands from everyone? Okay. We'll move on to the next question, and the next question is question number 14 on your sheets. So you can have a look at it. And solve the question. It is coming on the big screen now. Question number 14 from the sheet. And this is it. In a temperature scale called Z, the boiling point of water is 65 Z. And the freezing point is minus 14 Z. If the temperature is minus 98 Z, what is the temperature on the Fahrenheit scale? And I'll give you 2 minutes to solve this. Just my dear friends, do we have anything? I'll give you time, don't worry. It just requires a bit of calculation. The question is there with you on your table. Shall I help you, bacha? Why is it taking so much of time? Is it so difficult? Did I give a very difficult question? I don't think so.
Sir, it's 2.
It's 2 minus, okay, closest. So Aviram also says the same thing, minus 159. Let me check the answer. I have the answer sheet. Question number 14. Answer is 2. That is correct. Well done, my dear friends. How are we supposed to do this? It's pretty simple. I apply the concept. Which concept? Reading on any scale. Let me call it the Z scale. Minus the melting point on that scale. What is the melting point on the Z scale? It is minus 14. Divided by boiling point on the scale. Boiling point on the Z scale is 65. Minus the melting point on the Z scale, which is minus 14. That must be equal to the Fahrenheit scale ka values F minus 32 divided by 180. Do we understand this? Yes or no? For F, this temperature Z is given as minus 98. So I'll just put minus 98 here. Do we understand this, bacha? Yes or no?
Yes,
Huh?
sir.
You understand this?
Yes, sir.
Sir,
You just have to calculate F from here. It is a simple problem. It just requires some amount of calculation, which I think you are good enough to do it. Yes or no?
Yes, sir.
Pakka na, sir?
Pakka, sir.
Yes, sir.
Pakka na, sir? Shall I give you one more? Because my faith has my faith has got dagmagao, shattering. I thought that you would be able to do this, but since you could not do this, I shall present the next problem. And this is the next one. Unfortunately, this is not from your sheet, so you'll have to know. You don't have to note it down. You just have to consider the problem from the board and give me the answer. The freezing point on a thermometer is marked as 20 degrees and the boiling point is 150 degrees. A temperature of 60 degrees Celsius on this thermometer will be how much? Don't write the question. Don't waste your time in writing the question. Read the question, solve the answer, give me the answer, stay happy.
$98 degrees, sir.
Yes, bacha?
98 degrees.
98 degrees is the answer that I've got. All of you got the same answer?
Sir.
Yes, then it has to be 98 degrees. So how are we supposed to do this? I'll give you 1 more minute. Don't have to fall in the trap. It's a simple question and it has to be done as simply. Oops, what I've done here. Okay, this one. So this is a simple question. It has to be done as simply as possible. Yes, so what do? You just put the formula. The temperature on that scale, let us call it A. A minus freezing point is 20. Divided by boiling point is 150. Minus 20, that is 130. Divided by C is equal to C minus 0. This is C divided by 100. C is given as, my dear friend, 60. So I'll just cut this and I'll just put 60 here. The rest is pretty simple and straightforward. Yes or no? No, yes.
Yes, sir.
Okay, that finishes this part of the chapter. Anyone having any doubt up till now?
No, sir.
That takes us to different types of thermometers, and every thermometer is based on any one of the 4 properties that we have discussed. Yes or no? So it will either be a liquid filled in a capillary, either it will be some gas filled in capillary or some gas filled in something, or it would be a resistance of a wire which changes with temperature. Do we understand this? So now, if we have any type of liquid thermometer, number 1 is liquid thermometer, we can devise a formula for a liquid thermometer. In liquid thermometer, it will have a liquid filled in a capillary. That is the thermometer that we use. Doctor used to use a mercury thermometer. Yes or no?
Sir.
Liquid thermometer or mercury thermometer. Now in this mercury thermometer, you shall have mercury moving up and down depending on the temperature. Again, remember, this formula is exactly same as the formula that we had seen just now. I'm just going to write it in a different way. Temperature on the Celsius scale. Oops, why this has happened? Not good. Temperature on the Celsius scale shall be equal to L minus L0 divided by L100 minus L0 multiplied by 100. Do you see how this formula would have come? Temperature is assumed to be, the length of the liquid is assumed to be varying directly with temperature, and if I shall draw the diagram of this, the graph might look like this. No, it might not. It definitely looks like this, and that is how this formula has been derived, or whatever formula that we see are derived. I hope you can see this gentleman that I have drawn. This is the temperature on the Celsius scale, and this is the length of the liquid in the column. And my dear friends, the formula comes from this line. Oops, what has happened? Why is not a straight line coming? This gentleman is good. This is how we assume that what the liquid ka length varies with temperature. At this point, why I'm showing you this graph, because I don't know, maybe you will find a question of graph because they are very keen on graphs. So this will be the length at 0 degrees Celsius. When the temperature is 0 degrees Celsius, mercury will be somewhere on the capillary. Yes or no?
Yes, sir.
That is that length. And here the temperature, as you can see, my dear friends, would be 0 degrees Celsius. Similarly, when the temperature is 100 degrees Celsius, then also you shall have certain length of mercury in the column. Yes or no?
Yes, sir.
That is L100. Then if you know what is L0 and what is L100, you can make 100 divisions between them, and every division will correspond to 1 degree Celsius. Yes or no, my dear friends?
Yes, sir.
So if the temperature is T degrees Celsius, which I've written here, then it will correspond to a length LT. I can write it as LT or LC, whatever. I shall use the same thing. LT is LT minus L0 divided by L100 minus L0. I hope you can understand this is a straight line, and you can find out the value of LT. You can find out the value of T from LT, L0 and L100. Yes or no?
Yes, sir.
Yes.
Similarly, if I have to make a formula on the Fahrenheit scale, TF, what would the formula look like? It does not require physics, it just requires common sense. If I had to make a formula on the Fahrenheit scale, how would the formula look like, my dear friends?
LT minus L32 by
LT, well done, minus
L32.
length at 32 degrees Celsius, very correct, divided by
L212
L212 by
minus
L length at 212 minus length at 32 multiplied by what?
100.
Ah,
180.
180. It has got 180 equal divisions. Do you understand this, or this has gone above our head saying bye bye, I'm going, don't worry? This is all about liquid thermometers. If you understand this liquid thermometer, remember, Kelvin scale is not defined on the liquid thermometers, because Kelvin scale is only defined on gaseous or gas thermometers. You can also write a formula for Kelvin scale, but liquid thermometers we normally don't use it. Do we understand this? Yes or no?
Yes, sir.
And
Yeah.
remember this diagram, because this diagram may come in your examination hall, and then you should not be found wanting. Have you written this? Yes or no? No, yes.
Yes, sir.
That takes us to the next type of thermometer. Liquid thermometer is done. Then what is the second type of thermometer? Huh?
Gaseous thermometer.
Gas thermometer. And in this gas thermometers, we have two types of thermometers. One is known as constant pressure gas thermometer. Constant pressure gas thermometers.
Constant volume gas thermometer.
Yes. So you know a lot of things about this. Now, if I have to make a thermometer here pressure is constant, so volume is directly proportional to temperature. Yes or no? Temperature on the Celsius scale in this thermometer will look like what? Give me the formula. How will I write the temperature on the Celsius scale in this thermometer?
V minus
V at temperature T minus
initial volume.
not initial volume, volume at 0 degree.
Volume at
100
degrees man,
minus V0
into 100.
into 100. On similar lines, you can write the formula for the Fahrenheit scale. Yes or no?
Yes, sir.
Yes, sir.
Similarly, you can write the formula for Kelvin scale. Can anyone tell me what is the formula on the Kelvin scale?
VT minus V273 by V 375 minus V275.
Well done, my dear friends. And the formula looks like this. 273.16 into volume at T divided volume at triple point. That is the formula. It's somewhat different from the liquid and gaseous thing because that is the absolute temperature beta. Here we have assumed melting point as 0 degrees Celsius. Here we have assumed boiling point as 0 degrees Celsius. But here in the Kelvin scale, nothing has been assumed. No, one thing has been assumed. And that is known as the triple point of water. Do you understand triple point of water? It is that point of water where water can exist. It is that specific condition of volume, pressure, and temperature when water can exist in all the three stages together. Yes or no?
Yes, sir.
It can be gas, it can be liquid, it can be what? Vapor. And the triple point of water on this scale, that is the only assumption that we have taken. The triple point of water on this scale is how much? The triple point of water on this scale is 273.16 Kelvin. So there is 1.6 here and there was 1.5 there because the triple point is actually equal to 0.1 degree Celsius. No, 0.01 degree Celsius. And that is why it is not 273.15, it is 273.16. Do we understand this? What has gone above or saying bye bye? I'm going, don't worry about me. This is the formula for temperature on the Kelvin scale for a constant pressure gas thermometer. Do we understand this?
Yes, sir.
Can you write the formula for constant gas thermometers, constant volume gas thermometers? Constant volume gas thermometers. Right, fatafat. What will be the formula for temperature on the Celsius scale? Constant volume gas thermometer. Pressure at T minus pressure at 0.
P0 by P100 minus P0.
It has to be multiplied, my dear friends, by
Into hundreds.
if it was Fahrenheit scale, 0 becomes 32, 100 becomes 212, and that 100 becomes 180. Do we understand this?
Yes, sir.
What is the temperature on the Kelvin scale on this? The same thing. 273.16. Remember that is the triple point.
P by PTR into 273.16.
Yes. Pressure at the triple point. Is it making sense? Everything is making sense, yes or no?
Yes, sir.
Well done, my dear friends. If it is making sense, then we'll not talk sense. We'll talk sense and not nonsense. Everyone has noted this down?
Yes, sir.
Then you move on to the third type of thermometers. What are the third type of thermometers known as? Yes, my dear friends. Platinum
This is-
wire resistance thermometer, or I can simply call them resistance thermometers. Yes, and we start with temperature on the Celsius scale. How will I write temperature on the Celsius scale here? RT minus R0 or 100 minus
Can't see your
R0
screen.
multiplied by 100. Got this? This is how we can find the temperature on the Celsius scale in the resistance wire thermometers. Similarly, temperature on the Kelvin scale will be 273.16. Resistance at T Kelvin, resistance at triple point of water. I hope you all understand this, yes or no?
Yes, sir.
You understand one thing, one formula, if you remember any one, the rest of them all would come automatically, my dear friends. Yes or no? No, yes.
Yes, sir.
Sir.
Have you noted it down, everyone?
Noted, sir.
Noted, sir.
Noted, sir. Then, sir, a question, sir. Please do not write the question, sir. Just concentrate on the answer, sir. Unfortunately, this is not from your sheet, sir. A temperature is graduated. Temperature. A thermometer is graduated in mm. It registers -3 mm when the bulb of the thermometer in pure melting ice, and 22 mm when the thermometer is in steam at a pressure of 1 atmosphere. Temperature in degrees Celsius when the thermometer has 13 mm as the reading is how much? Give you 2 minutes. Give me the answer.
Sixteen by 25 into 100, sir.
16 by 25 into 100. I have got an answer. What about the others?
B, sir. Yes, sir.
B, sir. Yes, sir. Anyone understand this, sir?
Yes, sir.
How did you get this, sir? Please tell me, sir. So again, I just applied the same thing that we have been doing for the entire class. Temperature on that temperature on the Celsius scale will be length. How much is the length? It is 13 minus length at 0 degree Celsius, which is -3 mm divided by 22 minus of -3. This has to be multiplied by 100. Do we understand this?
Yes, sir.
So the correct answer would be answer B. No questions asked, no answers given. Yes or no?
Yes, sir.
One more, sir.
Sure, sir.
Yes, beta.
Give, sir, one more.
Yes, I give you one more because that that has come in JEE of last year. So that is why, not the exact values, but the exact question. Okay. This is the question that came in this year JEE, not last year. This year, Abhi, second term, second attempt, or the pehle wala attempt. Doesn't matter. The temperature coefficient of resistance. Oh, what is this? The temperature coefficient of resistance of a wire is 0.00125 per degree Celsius. At 300 Kelvin, my dear friends, the resistance is 1 ohm. What is the resistance of the wire at 2 ohm? The resistance of the wire will be 2 ohm at what temperature? Now you do not know what is temperature coefficient of resistance, but I have already told you the formula for resistance at different temperatures. Just for your thing, I will tell you the formula for resistance, temperature coefficient of resistance, and this is the formula for temperature coefficient of resistance. Please note it down. This is a question taken from your electric current wala chapter, but it is actually a question of temperature. R at any temperature will be R at 0 degree Celsius, because this is in per degree Celsius. 0 degree Celsius into 1 plus alpha into temperature, what temperature it is in degree Celsius. Do we understand this formula? From this formula, we have derived the formula that I gave you. Do we understand this? So this is the hinge. 2 minutes for the solution.
Option C, sir. Sir. Sir.
Sir. Aru.
हाँ मेरा बच्चा आया आंसर. Did you get the answer? Yes,
Option
no,
C,
no,
sir.
yes. It will require a bit of calculation, beta. Yes. Did anyone get the answer? A, B, C, D. Which one?
Option C, sir.
Option C, 1400 Kelvin. The answer that I have is option D, 1127 Kelvin. Remember, this formula is for degree Celsius and this one is given in Kelvin. Remember that. Now, what is 300 Kelvin? 300 Kelvin, my dear friends, on the degree Celsius, and that is why this question was given, is 27 degrees Celsius. Do we all understand this? Yes or no? No, yes?
Sir. Yes, sir.
That is how you will write it. Resistance at 27 degrees Celsius divided by resistance at the given temperature T, that will be equal
Yes,
to
sir. Option D.
R0, resistance at 0, which is not given, 1 plus alpha into 27. Do we understand this, my dear friends?
Yes, sir.
Divided by R0 into 1 plus alpha at T degrees Celsius. Do we understand this, bacha?
Yes, sir.
R0 and R0 gets cancelled. You just put the value of things that are given. At 27 degrees Celsius, my dear friends, L01, what is the resistance? Tell me.
1.
It is 1. Yes or no? Raise your hands, will give you more confidence.
Yes, sir.
At T degrees Celsius, which we have to find out how much is this T, that the resistance is given as 2 ohms, yes or no?
Yes, sir.
Yes, sir.
And this T is what you have to find out. You can easily find out. I think the answer you will get. Remember, it will be in degrees Celsius. Remember, it would be in degrees Celsius. Remember, it would be in degrees Celsius. Do we understand this?
Yes, sir.
You can solve it, and I think the answer in degrees Celsius that you shall get will be 854 degrees Celsius. And then you convert from degree Celsius into Kelvin, and you have the answer, my dear friends. Do we understand this? Yes or no? No, yes.
Yes, sir.
Pakka, sir?
Pakka, sir.
Kacha wala pakka, sir, ya pakka wala pakka? Kacha.
Kawala Pakka.
Okay, I hope you understand that much of Hindi, that kacha wala pakka and pakka wala kacha. Kacha means not ripe, and pakka means ripe. Pakka means pakka and kacha means kacha. Okay. Anyone understands this? Let me find if I can get one more question which I have. Yes, I think I have here. Resistance. I don't have resistance. Don't have it for resistance. Don't have it for resistance. Don't have it for resistance. I don't have it for resistance. Okay, I have one question from here. I'll just okay, you're done this, so not issue. Okay, let us move ahead in life. Life, we have to move ahead always. Life cannot remain stagnant at one point. Do we understand this up till here? So far, so good?
Yes, sir.
They say yes, sir, or no, sir, na? Yes, sir, na?
Yes, sir.
Yes, sir.
Okay. Now, we have seen that we have used certain property of liquid or gas that changes when the temperature is changed. Yes or no? So that automatically brings us to the next topic. We have seen that the volume of the liquid changes when the temperature is changed. What happens when the temperature is increased? Does the volume increase or does the volume decrease? Huh? Are?
Increases.
The volume increases. We have used that property to make a temperature scale. That phenomena by which the volume or the length or the area of a liquid, area, not length of a liquid does not change, length, area, volume of a solid or the volume of liquid changes, that phenomena is known as, my dear friends, what? What is it known as?
Can you repeat, sir?
The phenomena by which the length, area, or volume of a solid or volume of a liquid changes with
Thermal
temperature.
expansion.
Thermal expansion, and that is the next heading that we are going to do because it is as related to what we are doing, and something is going to happen now. My thing is going to stop. I don't know why. Automatically it just switches off and tells me that we have had enough of this. So now, okay, I hope you get it now. Okay, so that phenomena, I think I pressed this button for long and that is why this thing happens. I must be careful. That phenomena is known as thermal expansion. Do we understand this thermal expansion, my dear friends?
Yes, sir.
Okay, I have live visuals from the other class. There was a point in time when all these channels. I mean, right now this is the world of OTT platforms. But before the world of this OTT platform, there used to be channels. Do you know channels? Z TV, Star TV, this TV, that TV. Before that, there was only one TV, and that was known as Doordarshan. And anyone heard about Doordarshan? Doordarshan, the national television, my dear friends. There used to be national television, and when we bought our first TV, I think 1984, the TV had 12 channels. Tuck, 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 gold that round, tuck, 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 tuck. And we used to wonder why there are 12 channels when only one channel is coming, that is DD. That time it was used to come from 6 o'clock or 5 o'clock in the evening till 10 o'clock in the night. And then they started morning session. Now, before that television, everything used to be on radio. We used to listen to commentary on radio. Sometimes matches used to happen. And then we had this commentator, Doshi sir, who used to say, live visuals aa gaye hamare paas. So right now I have live visuals of the other class. That reminded me of that old live visual thing. Okay, we have live visuals from the other class, and we are live here on thermal expansion as well. No matter what type of body we have, if we change the temperature, something changes, and that is known as thermal expansion. Yes or no? The phenomena of thermal expansion can be seen in solids, it's seen in liquids, as well as it is seen in gases. Yes or no? Say yes or no.
Yes, sir.
Yes, sir.
In which type of bodies is thermal expansion maximum?
Gas, yes.
Gas. In which type of bodies is the thermal expansion minimum?
Solids.
Solids.
What is the reason of this thermal expansion? And this question has been asked many times. So this graph, without understanding anything, you just have to draw this graph. And remember that this is the graph because of which thermal expansion happens. I will tell you whatever I know about this graph, and you just have to contend with that one. This is the graph that you will have to remember, draw, and see. Now, if I draw the potential energy, and then this potential energy is the potential energy of the atoms and the molecules which are inside any body. If I draw a graph between potential energy and the distance between those atoms and molecules, this graph is not symmetrical. Do you see this graph is not symmetrical?
Yes, sir.
Yes, sir.
You would also know from your chapter on work power energy. I know you have given me the list of work power energy in the points that we have to discuss. We have seen that potential energy is minimum, stability is maximum. Yes or no?
Yes, sir.
Yes, sir.
You can see here at this point the potential energy is minimum. Yes or no?
Yes, sir.
At that
sir.
point. Now this is the distance that the molecules should keep themselves at, so that they can stay stable and the size and shape of the body remain same. Now, if you try to increase the distance or you try to decrease the distance, the potential energy graph is not symmetrical, and that is why when you change the temperature of that body, their energy changes, and therefore their distance between each other also changes, and that is why you have thermal expansion. Do we understand this?
Yeah, sir.
At different energies, the minimum separation changes, and therefore when you change the temperature, the energy changes, and the body either expands or the body contracts. Do we understand this?
Yes, sir.
Yes or no?
Yes,
Okay,
sir.
that is the reason
Yeah.
of thermal expansion. Now, this thermal expansion we will study under two heads. One is the thermal expansion of solids, and the other one would be thermal expansion of
Thermal expansion of
Liquids.
liquids.
liquids. Thermal expansion of gases will not be studied here. Thermal expansion of gases will be studied in the chapter which is coming up, thermodynamics, because then you will have volume expanding, volume contracting, adiabatic, Palana, and other things. Yes or no? Okay, so we
Yes,
will
sir.
only study thermal expansion of what? Of what?
Solids.
We'll only study the thermal expansion of solids and
Liquids.
liquids. Now, this is the first question that comes in thermal expansion. If you have a sheet, and you don't have to draw the question, it's from your module only. If you have a sheet, any shape of any shape sheet, and you have a hole inside that sheet, What happens if you expand? If you increase the temperature of this sheet, what happens to the hole that you have? Does the volume of the hole or does the area of the hole, does it increase or does it decrease? Then they can ask you, for example, here, let us say, if I ask you what will, if I increase the temperature is increased, what happens to this length A? Does it increase or does it decrease?
Increase, sir.
Increase.
Okay. What happens to this breadth B? Does it increase or does it decrease?
Increase.
What happens to this C? Does it
Decrease.
increase or does it decrease?
Decrease.
How many for decrease? How many for increase? Remember, this is not an election, a democratic election. So that means that if all of you are telling me the wrong answer, that does not make it the right answer because it is democracy. Yes. C. Will it increase or will it decrease? This is increase.
Increases, sir.
Yes, it will increase better. That means when it expands, it will not expand inside the hole. The hole will also expand. Do we understand this? That was the point that I had to make. Do you understand this? The hole
Yes,
also
sir, yes,
expands. What about this D? Does it increase or does it decrease?
Increase.
It will also increase. Do we understand this? This phenomena is known as the phenomena of what?
Solid.
Expansion of solids.
Expansion of solids. Do we understand this? Yes or no?
Yes, sir.
Now, when we are studying the phenomena of expansion of solids, we'll have to study it under how many headings?
3.
Why 3? Why 3? Why not only one? Why 3?
Linear,
Linear, then
aerial,
aerial, then
Volumetric.
why it is so? Because if I just you already know it, so that's why I'm putting this. Thermal expansion is minimum in case of solids and maximum in case of gases. You already know this, yes or no? The reason is the forces are stronger in case of solids and weakest in case of liquids, in case of gases. Now, whenever we talk about the expansion of solids, my dear friends, solid expand in one dimension. This statement is not actually correct. See, whenever we are talking about solids, whenever we're talking about solids in physics, or we are talking about bodies in physics, even though everything that we see is a three-dimensional thing, no matter how thin it is a three-dimensional thing. Yes or no? But for our discussion, what we have done is if we see what? If we see something which has one dimension very large and the other two dimensions very small, for example, this line or a thin wire or a thin string in mechanics, even though it is a three-dimensional object, what you see here is one dimension, which is the length, is very large compared to the other two dimension, width and the thickness. Yes or no? Therefore, this type of body will be treated as a 1D body. Do we understand this?
Understood,
Even
sir.
though it is 3D, just for simplification, we will take it as 1D. Do we understand?
Yes, sir.
yes, sir.
Okay. Now, similarly, if I have a body like this, now even though this body is a 3D body, three-dimensional body, but its one dimension, which is the thickness, is very small compared to the other two dimension, length and the width, such type of bodies will be treated as 2D or two-dimensional bodies. We understand this?
Yes, sir.
Yes, sir.
Rest all of the bodies will be taken as 3D bodies. So this body only has length, this body only has area, and the other body has length, area as well as volume. So we'll treat it as a volume. We will treat that body as body having volume. Now, when I change the temperature of this one-dimensional body, though it will expand in volume, but instead of taking this expansion as volume expansion, we will take it as expansion in length. Do we understand this?
Yes, sir.
Yeah, sir.
That expansion is known as linear expansion. So this type of body, we will assume that they will expand linearly, that means in length. This type of body, they will expand in area, we call it superficial expansion. And any other body will expand in volume, we will call it volume expansion. It will expand in 3 dimensions. Yes or no? Everyone understands this point?
Yes, sir.
Everyone has gone through this point?
Yes, sir.
Okay, so the first heading is, you have written this down, bacha?
Writing, sir.
Write it. I hope everyone is doing it.
Noted, sir.
Noted? Everyone?
No, sir. Wait, sir.
Okay, sir. Do we have competition between the two classes? Who will note first? Who will write first? Who will do first? Something of that nature? Do we compete or do we don't? Because, I always see that, if one class comes, they ask, sir, please start the class. The other class comes and the first class does not come. The other class says, sir, please start. Is that so?
Yes, sir.
Why, sir? Okay. Healthy competition
Completed,
is
sir.
all. Yes, bacha?
Completed, sir.
Completed, sir. Then fatafat we will write this, sir, and I've just put it so that I don't waste time in writing. This is my original wire, thin wire. It has been drawn thick, but I hope you understand that this is a thin wire. Yes or no? So this is my original wire, the original thin wire, and the original length is L0. Do we understand this? Before heating, everyone?
Yes, sir.
Say na, yes sir, na. My one thing has gone.
Yeah, sir.
Yes, sir.
Yes,
Okay.
sir. Yes, sir.
When I increase the temperature by delta theta, here it is written as delta T. I might write it as delta theta. Oops, wrong color. I might write it as delta theta. So what happens? It expands. And the change in length is delta L. So this delta L, or the change in length, can be written as alpha into L0 into delta theta. Do we all understand this, my dear friends?
Yes, sir.
Ha, sir.
Remember a very important relation. I can write this small change as dl, and this will come in JEE Advanced. The small length as change in length as dl, that will be
Alpha
equal
L
to
naught
L.
into d theta.
Yeah, so instead of writing it here, I can write it here also. You understand this, bacha?
Yes, sir.
Okay. So this is how you can write it. So from here, you can write the value of alpha also, my dear friends. Alpha will be equal to 1 by L0 times dl by d theta. I hope everyone understands this. The final length L can be written as L plus delta L, or I can write it as L0 into 1 plus alpha delta theta. This alpha, my dear friends, is known as coefficient of linear expansion. Do we understand this?
Yes, sir.
Yes, sir.
Okay. I'll give you 1 minute to note this down. Remember, here we have assumed that this alpha is constant. This alpha is treated as a
Constant.
constant. What will happen if alpha is not a constant? Yes, my dear friends.
Irregular expansion.
Yes, irregular expansion, and we will also discuss that. But first things first. First thing first. to note this down, then only I shall move ahead in life.
Sir,
Yes, sir, bacha.
sir, does the internal state of body changes during expansion?
Internal?
State of the body.
What do you mean by internal state of the body, bacha? What do you understand by internal state? See, when the
Like distance between the internal.
yes, it has to change. You have seen that graph, no, beta? At different energies, depending on now these energies are coming from the temperatures. At different temperatures, the separation changes. So the separation changes. That is why they expand. No, bacha?
Yes, sir.
So it's because of the change in the separation that they expand. What was your question again? Do you understand this? Or whatever I have tried to explain? I could
Yes,
not
sir.
understand your question, but
Yes, sir. Yes, sir.
anyone has noted this down, bacha?
No, sir.
You just have to note down, not that entire thing. You just have to note down this one, this one, this one, this one, this one. Rest is just the explanation. You just draw the original length. This is the original length, my dear friend, and this is the new length, L plus delta L. That's it. Remember, the questions on this particular topic will be very, very, very simple. The only problem here is, what is the problem here? That they will have alpha, beta, gamma, and such things. And remember, this alpha, beta, and gamma, my dear friends, they are very, 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 very small. Do we understand this, bacha?
Yes, sir. Yes,
Yes,
sir.
sir.
That they will be very, very small, and therefore they will require what? They will require some calculations, and we can't avoid that calculations. Okay, we understand this.
Yes, sir.
Have you done the thing, sir?
Completed, sir.
Okay, take your time. See, even though we are trying to finish the topic, it's always good to finish one topic fully rather than doing 15 topics and only doing 10% of that 15 topics. Do we understand this? Whatever we are going to do, we are going to cover it. And trust me, we'll try to cover everything. Don't worry. The only thing is the number of questions might just decrease. I'm not going to leave anything out. I might, instead of doing 5 questions, I just might do 1 or 2. That is the only difference, and that is why I've sent you that sheet, so that you just do all the questions from that sheet. Done?
Done, sir.
Done, sir. Then, sir, this question will come to lock the concept in our head, sir. And remember, it's not necessary that always the question comes in the same form that you expect. It may be coming in a different form, but try to understand this question has come in JEE, but try to understand that the question just requires the same thing. And this is the question. This question might come in that percentage error wala thing, percentage change wala thing, but this is actually a question of thermodynamics. This is also a question of that error measurement, all those things. We understand the language of the question, yes or no? You understand what I'm saying here, right? Understand that?
Yes, sir.
What is the percentage change in the length of a 1 meter rod if the temperature changes by 100 degrees Celsius? Alpha for the rod is given as, and remember that the only problem with this question is that value. What is the percentage change in length? And I wait for your answer, my dear friend. I hope I am audible and visible to all. Percentage change in length, my dear friends.
0.2, sir. Percentage.
0.2%. That is great. Well done.
0.2, sir.
Well done. I hope everyone is doing on their own and not just repeating answers from the fellow participants. Oops. Okay, so how are we supposed to do this? Basically, we have to find out the change in percentage. So basically, we have to find out del L by L or delta L by L into 100%. Yes or no? This is what you need to calculate. Yes or no?
Yes, sir.
Yes.
How are we going to do this? We know that del L by L is what? This is A times d theta. Yes or no? Change in temperature. So we have to multiply not A, alpha, sorry. This is alpha multiplied by delta theta multiplied by 100%. Yes or no? It comes from the concept that we have written this already in this form, my dear friends. 1 by L into dl by d theta. Everyone understands this? A quick raise hands from everyone will give me more confidence that we are in the same universe. Yes or no? Okay, so I think this is done. First type of problem. Then comes I think in your sheet I had not given thermal expansion, so I'll send you the sheet of thermal expansion as well. Okay, in your sheet it was calorimetry and thermometry. I was thinking of doing calorimetry, but then the thermal expansion thing came up and I thought that it's better that I can do it here. So things keep on changing. We understand this, yes or no? Can you move further ahead in life? Life has
Yes,
to move
sir.
on.
Yes, sir.
This is the next question that we are supposed to do. Question of thermal expansion is the easiest one. Now remember, the only problem in this question is the calculation. That's it, and I can't help. I can't do anything about that. The design of a physical instrument requires that there is a constant difference in length of 10 centimeters between an iron rod and a copper cylinder laid side by side at all temperatures. If alpha for iron is something 10 raised to the power minus 6 and alpha for copper is something, what are their lengths? And you shall have 2 minutes of time to solve this. And I hope that is good enough to do this.
Option A, sir.
Option A, sir. I think that is the correct answer, sir. Well done, sir. Have you done this question before, bacha?
No, sir.
Okay, then that is greater. That is better. Well done. What about the others? Shall I do it for you? No, yes, no.
1 minute, sir.
Okay, I'll give you time. Don't worry. Time is a luxury that we don't have right now. One more minute. Remember, it's a simple question. Every question that comes, the first thing that you have to understand is that it is a simple question. And if it comes in the examination hall, whether it is JEE Main or NEET or advanced, remember you might not have so difficult calculation. They may just give you simple values, or they may give that question in alpha numeric form, where they will call one length as L1, the other length as L2, and so on. Yes. Anyone who can tell me how it is done? Or shall I do it? Okay.
Alpha into L1 is equal to alpha into L2, sir.
Yes, that is what you need to ultimately land up here. See, remember, the answer to every question is hidden in the question itself. The question says that there must be a constant difference of 10 centimeter between iron and copper. And that will help us in solving the question, my dear friends. So I will write it like this. Length of iron, L at F, length of iron minus length of copper should be equal to 10 centimeters. Yes or no?
Yes, sir.
It has to remain
Sir.
fixed. Now, if this difference in length has to remain fixed, the change in their length should also remain same. The change in their length should also be same. So if I differentiate this, delta L of Fe minus change in length of Cu, that must be equal to 0. Yes or no?
Yes, sir.
That means change in length of Fe shall be equal to change in length of Cu. This does not require physics or math. This just requires common sense. Yes or no? If the length, the change in length, if the difference in length has to remain constant, they both must expand by the same amount. Yes or no?
Yes, sir.
That's it, my dear friends. What is the formula for change in length of any body? It is equal to alpha into length, alpha of iron into length into delta theta. Do we understand this, bacha?
Yes, sir.
Similarly, we have alpha of copper, length of copper into change in temperature. The temperature has to be changed by the same amount. So we have this. Let me make a line here. So we have length of iron divided by length of copper is equal to, I hope I do not make a mistake, alpha of copper divided by alpha of iron. Yes or no?
Yes, sir.
Alpha of copper, my dear, is given as 17 into 10 raised to the power something. This is 11. So this is 17 by 11. Alpha length of iron divided by length of copper is 17 by 11. Yes or no?
Yes, sir.
Now you can call this as equation number 2, and I can call this as equation number 1. I know that you are good enough to solve these two equations. Yes or no?
Yes, sir.
So I may not waste my time and your time and the time of this class. You should be able to solve it from here onwards and give me the value of length of iron You just have to find one, because once you get the value of one, all the other options are different. Yes or no? So I think you will get the length of copper as 28.3, and that finishes the question then and there itself. Do we understand this, my dear friends?
Yes, sir.
Sir.
I need a raise hands from everyone in the class that we understand this. Online class, offline class, everyone. Girls, boys. Okay, good. Yes, bacha? Tanu, Abhiram, Yashwant, I hope. Astik, acha, Astik is me. Okay. Everyone understood this? Okay, I'll give you one more question, and
Yes, sir.
I'll give it to you. Remember, beta, I can't help it, but whatever questions we will, I will, or anyone will create, they will have some calculation. So I'm trying to get the calculation. I'm trying to get the calculation. I'm trying to get the question which has the least calculation. Okay. I may succeed, I may not. This is the next question, and I hope that I get the answer straight away. This is just to make you understand that whatever question comes has to be done with whatever I have told you, and no question is out of your reach or that you cannot do. A brass rod and a lead rod, each 80 centimeter long at 0 degrees Celsius, are clamped at one end and their free ends coinciding. The separation of free ends of the rod if the system is played in a steam bath. So basically, what they have done is, this is one rod, this is the other rod. They have clamped it at one end, and the other ends are free. Do we understand this? We understand this? Yes or no? No, yes. See, the diagram is not given, so you must understand this. This is my, let us say, brass rod, and this is my, let us say, lead rod. Okay, so they are clamped at one end, and the other end is free. What is the separation between the free ends of the rod if the system is placed in a steam bath? Steam bath means temperature has to be 100 degrees Celsius. We all understand this, yes or no?
Yes, sir.
2 minutes you shall have. Even if you can't get me the answer, get me the concept correct, because getting the answer might require a bit of calculations, and I can't avoid it, no matter how hard I try. This is the easiest question that I got in terms of calculation. All the questions are similar. The only problem is their calculations. And I don't want you to get crap with calculations.
Find the final length of brass.
But we have to find out the separation between the free ends. So we need to find out the subtraction of these. Got it?
Yes, sir. Finding out final length and making the difference.
Yes, but again, you can simplify your calculations by subtracting them. Finding the final length of lead, finding out the final length of brass, and subtracting them. That is it. Their initial lengths are same, so that will get cancelled from both ends. Do we understand this?
Yes, sir.
So may I have the answer, sir?
Sir, option B.
Option B. Well done. 0.8 mm. That is correct. Good. Well done. 1 more minute to everyone else. I have 12 minutes left, and I have to cover 2 more things. So how are we supposed to do this? Anyone? How are we supposed to do this? Anyone? I have to find out the length of the brass. Length of the brass will be L0, and L0 already is given as 80, yes or no? 80 into 1 plus alpha of brass multiplied by change in temperature. How much has the temperature changed, my dear friends?
100 degrees
100.
Celsius.
Temperature has changed by 100. This is just to make your calculations simpler. Then I go on and find out the length of the lead rod. That is again equal to 80 into 1 plus length of lead. I think lead is PB, if I remember it correctly, into 100. I have to find the difference between their free length. So basically, I need to subtract this. Yes or no?
Yes, sir.
These two gentlemen will say bye-bye. So you will have a simple answer. Length of brass minus length of lead, PB, will be equal to alpha brass into 80 into 100 divided minus alpha lead into 80 into 100. So 80 into 100 I have taken outside. Alpha brass is 18 minus 28, or you can do 28 minus 18, assuming that this lead will be more and brass will be less. This will be your answer into 10 raised to the power minus 6. Yes or no, my dear friends? I
Yes,
think it
sir.
is coming as 0.8 mm. Raise hands will from everyone will give you more confidence that we are there somewhere. How many of you were able to do this? Please raise hands on your own. Good. I have a lot of students, so I will now take this away. Remember, this was the case where your alpha was constant. Yes or no? Now you
Yes,
can
sir.
write a case where alpha is variable, and I will just try to give you a question on that. What happens if alpha is variable? Now alpha can vary with two things. It can vary with your length, or it can vary with your time, with your temperature. So there are two ways in which I can vary alpha. It can vary along the rod, along the length of the rod, or it can vary with temperature. Now this type of question will not be coming in NEET. It may not even come even beyond probably JEE Main. It is more in the territory of JEE Advanced, between JEE Main and Advanced somewhere. So if your alpha varies with temperature, if they make the NEET paper very tough, then probably this can come. I don't think they are so big fools. So if it varies with distance, you can use this formula. Change in temperature would be given to you. It will vary with distance, so you can write the total change in length delta L is equal to integral of alpha will be varying with distance. Some sort of formula would be given. You can integrate it. Do we understand this? Yes or no?
Yes, sir.
If alpha varies with temperature, alpha will be given as a function of T. You can find the change in temperature. From here, I will give you one example from both and try to make some sense out of this. Please note down this.
Sir,
Yes, beta.
I sent one question in Telegram, sir. Once check out.
Okay, but I'll see it. I don't have Telegram open right now.
Okay, sir.
Don't worry, I will do that. Have you noted down that thing? Shall I give you a question?
Yes, sir.
So this is the question. That is how the question is made. You have a rod AB of length L, original length L. From the end A, if you move a distance x, the alpha, the value of alpha varies like this: 2 times x plus 3. It could be any function, a simple function. Now the temperature of this rod is being changed by a temperature change of delta theta. You have to find the change in length delta L of the rod. Do we understand this?
Yes, sir.
You have 2 minutes to solve this.
L square plus 3L into delta theta into L.
Okay, but the question that you have given cannot be done now because we have just done expansion of solids. It also has liquid, so we can't do it right now. Okay.
Yes, sir.
Who sent me the question?
Santosh, sir.
Santosh, beta, we can't do it now. And whenever you say, if you send the question like this, I have to read it like this. And it becomes very cumbersome for me. Send it like this. Okay.
Okay, sir.
We can't do it because it has what I understand, it has water, it has expansion of water and all those things. We will do that. And don't worry, such questions are very unlikely to come with the values that they are given. We'll do a similar question, don't worry. Okay. Don't worry. We have just started expansion. We have only done expansion of solid. We have not moved on to liquids. Expansion of solid also has a lot of things that we have to cover. Everyone got this? Yes or no?
Yes, sir.
So how do I find it out? I can straight away use. See, the actual way is this. It is alpha into L into d theta. Yes or no?
Yes, sir.
Now here
Yes,
the
sir.
change in temperature is given. So instead of
Integrating on
writing,
both sides.
yes, beta. Do we understand this much?
Yes, sir.
Okay. Now how this question is actually done is we move a distance x, then we take a small segment of length dx, and then we found out the length is dx, the change in temperature is delta theta, we integrate it and all that. To cut everything short, we can just get this formula like this. This will be equal to alpha into delta theta into delta theta into dx ka integral. The ultimate thing that you will land up is this one. Do we understand this, bacha?
Yes, sir.
With all those complicated maths, we don't have that much time that I do all those complicated maths. We can just do it. So it will be integral of, arey yaar, it will be integral of 2x
X plus
plus
3
3 dx,
dx dt delta.
and this has to be multiplied by a constant. This constant is delta. This constant is delta theta. Do we understand this? And x
Yes,
has
sir.
to be integrated from 0 to L. Anyone understand this simple integration? Yes or no? So I will have delta theta coming here, and I will have 2L square by 3 plus 3L, and that would be the answer that we would be looking at. Yes or no?
Yes, sir.
Anyone understands this?
Yes, sir.
Yes, sir.
I can make a similar question on similar grounds. Anyone has noted this down, bacha?
Yes, sir.
Noted.
I can make a similar question on similar grounds. I can make a similar question on similar grounds. Instead of alpha varying with length, I can make a question. Then you can write this question. Alpha varies like this: 2 into theta plus 3. Theta varies from 0 to t. Length of the rod is L. Find total change in length. You can do it? Yes or no? What I have done here now is, instead of theta, instead of alpha varying with x, I have taken alpha varying with theta. Do we understand this, bacha?
Yes, sir.
Now, how will the integral look like? Can anyone just show me the integral? How does the integral look like for this one? I've just written the answer in the shortest possible way that I could. How will the integral look like for this case? Change in length delta L will look like integral of alpha into L into d theta. Do we understand this, bacha?
Yes, sir.
It will look like integral of L multiplied by 2 theta plus 3 d theta, integral of this theta from 0. Okay? Everyone got this? Yes or no?
Yes, sir.
So that brings us to an end of this class. 2 hours have passed and we were able to cover thermometry and we were able to cover one part of linear expansion. One or two things still remain in linear expansion. We'll cover that. Areal and volume expansion we'll cover in the next class, and then we'll try to move on to the next topic, which is calorimetry. So that is how we'll go. I'll see if I can extend this class to more time so that we can cover that entire thing in the next class. Okay, if you have any doubts, you can ask me. You can put it on the Telegram group, and whenever I get time. Today I have time. Normally I don't have. Today I have some time. So if you have any doubts, you can put it there and I'll try to solve them. So I'll wind up this class now. Take care and God bless you all. I'll see you soon. I think tomorrow, right?
Yes, sir.
Take care. Bye bye.